Hello, everyone. You have tuned in again with Learning Stats with Sid. Today, we are reviewing Pearson's correlation coefficient, which is also known as Pearson's R. Ultimately, this test shows the linear relationship of two factors on an interval or ratio scale. We're going to begin with my research question, which is there a relationship between social anxiety and self-esteem? As always, we're going to move next to our research hypothesis following the research question, which is I believe that there is a relationship between social anxiety and self-esteem. We're going to go ahead and write our IV and DV, aka the independent variable and dependent variable. Our independent variable is social anxiety, and our self-esteem is our dependent variable. I always remember this by saying, whatever is dependent on the other reaction. So self-esteem is dependent on social anxiety, and these are both measured on an interval scale. And after we decide and state our hypothesis and our alternative, so our P equals 0 for our null hypothesis, and our alternative is that we believe that P does not equal 0. We have a total of 47 participants, which makes our degrees of freedom 45 if we subtract it by 2. This statistical experiment had no missing data. And here is the fun part. We're going to calculate our mean so we can get our x minus means sum, and then we can get our x's squared value. And after we get the squared value, we can find our sum of squares of variable x, and then we're going to find the same for variable y, which again is social anxiety and self-esteem. So I know this looks all over the place, but on the left side is our x variables, and on the right side is our y variables. So our y variables are the self-esteem scores, and our x variables are the social anxiety scores. After I sum up all of the means for both x and y, we subtract each of the scores by the mean, and after that, we square each of the x and y's results, and we sum each of those columns sums of squares, and we get our sums of squares x and sums of squares y. And now we can multiply both of our findings from the original x minus mean and y minus mean, and we get our sums for x and y. And now we are going to draw out our normal distribution table, and what we find is that it is a two-tailed test, first off. Secondly, we're going to go ahead and put those numbers that we found from our DF, which is 2.14 from the number 45, which was our degrees of freedom, under our normal distribution table. And our alpha was 0.5, so we have to put that above our table as well. After that, we put our regression number, calculated number that we find, which was 0.09 and not 0.9. I don't know why that's there. And we retain our null. So for our sums of squared x, we get 78.6746, and for our sums of squared y, we get 254.32. Our sums of x and y, we get 12.7384. which resulted in our R, which is 0.09, and a whole bunch of other numbers. No, but seriously, once you calculate it all out and round it out, the R ends up equaling 0.095, but the original number is 0.094828928. See why I didn't say it. But this also means that we retain our null hypothesis because it wasn't equivalent to our crit, which our critical was 2.14 because we had such a larger sample number. And this is about it for Statistics with Sydney. Please be tuned in next week as we go into multiple regression. I hope you all were able to learn something. Have a great rest of the week. Bye-bye.